so I need us to think about for a second, just no Desmos, just thinking about this. What numbers could we plug into this that would give us 0? Oops. Okay, I heard 1. Okay, if I plug in 0, thank you. If I plug in 0, I would have 5 times 0 squared, 0 minus 4, 0 plus 2, and 3 times 0 minus 5, right? That'd be 5 times 0 times negative 4 times 2 times negative 5. What is that going to give me? 5 times 0 times negative 4 times 2 times negative 5 gives me 0 because I've got a 0 in it, right? So definitely x equals 0 is one of the answers for this. What else? It's not the only number. What's another number that would make this whole thing 0? How did you answer this so quickly whenever I had 5 times 0 times negative 4 times 2 times negative 5? There's 0 in it, right? So, if any part of that that's multiplied together equals 0, everything's going to be 0, right? So, you don't really have to look at the whole thing. You need to look at each little piece. Give me another number that would make this 0, that would make a piece of this 0. 4, right? Because if I have 4, I'd have 5 times 4 squared times 4 minus 4 times 4 plus 2 times 3 times 4 minus 5. So that gives me 5 times 16 times 0 times 6 times 12 minus 5 is 7, right? And all of that equals 0 because something is 0. So you got x equals 4. There is another something that would make this function have f of x equals 0. All right, give me another number. There's 2 more. Negative 2, because I'm not going to write everything out, but that would make this negative 2 plus 2, which would be 0. And then it wouldn't even matter what all the other stuff is because you're multiplying it by 0, right? So that would be 0. All right, last one's the hardest one to find. It's not a whole number. What? It's not 3.5. It's not, I mean, we've already got 0. It's not a whole number. Not 0.5. No. Okay. Which one of these pieces have we not made 0 yet? This last one, right? So we're thinking about what number I could put there for the x that would make this last piece right here equal to 0. This is the question we're asking ourselves, right? I want 3x minus 5. I want that to equal 0. Does that help? X will equal 5/3, right? That's what's going to give us 0. So Shay figured that one out. You can just like set it equal and solve. Essentially, you're doing the same thing over here. It's just you don't have to because it's so much easier, right? You were saying what would make x minus 4 equal 0. Well, that was easy to think about. It was positive 4, right? But you could do the same thing. You were adding 4 to both sides, so x equals positive 4. Okay? So, what we should be seeing here is that if one piece of this equals 0, the whole function equals 0, right? So, in the blanks down here, we're going to say if x minus c is a factor of a function, then c is a 0 of that function. And remember, zeros are anything that make our function equal 0. What do they look like on the graph? We've talked about zeros quite a bit. What do they look like on the graph? They're x-intercepts. If they're real, right? Real zeros show up. If they're imaginary, then we can't see them on the graph. But we'll talk about that here in a minute. Okay, so all right. So if I'm asked what are the zeros of f of x equals 3x minus 2, x plus 7, x minus 4, I can type this into Desmos and look for the zeros, right? It's not that hard to do. So let's just do it real quick. Just to actually, let's do it this way. Put extra Desmos over here. So let's just type that in real quick. I've got f of x equals 3x minus 2, x plus 7, x minus 4. I can type it in Desmos. I got 1, 2, 3 zeros right there. All right, I can just read those off. So I've got, if I use Desmos, I'm getting negative 7. X equals, what else did I have? 0.6, that's going to be 0.6 repeating. It's rounding it to 3 decimal places, and 4. Right? So Desmos works fine. It's, if you want to do these problems that way, it works. You can also do these really quickly without having to graph them, because if one piece of this is 0, it makes the whole thing 0, right? So you could say 3x minus 2 equals 0. If I add 2 to both sides, I get 3x equals 2. So divide by 3, x equals 2/3. X equals 2/3 is the same thing as 0.6 repeating, right? I got x plus 7 equals 0. You probably can do that part in your head. You don't even have to write it out, but if you did, it'd look like this. You'll get negative 7 for that. There's that answer that we had. And then we got x minus 4 would give us positive 4. There's our third one. Okay. Okay, everybody okay there? All right, so without graphing this, let's try to figure out this one, and then we'll go check it using Desmos. Okay, so for example 2, who can give me 1, 0 for this? Okay, x equals 2 is correct. That comes from this one right here. All right, 2 minus 2 would give me 0. What else? Negative 3. That'll work. That's that part right there, right? That'll give us 0. What else? Okay, x equals 0. That comes from this very first part, right? Because 3 times 0 would give us 0 right there. All right, there's one more. It's a harder one. 3 over 2. And that comes from this last part right here. You might actually need to set up that equation. It's just a simple two-step equation. 2x equals 3. Divide by 2. Divide by 2. X equals 3/2. So I've got 4 zeros that should show up for that. If we go over to Desmos to check what we're doing here, we will have f of x equals 3x times x minus 2, x plus 3 to the second, and 2x minus 3. So if I graph that, I've got negative 3, I've got 0, I've got 1.5, which is 3 divided by 2, and 2. So I got those 4 zeros right there. Now there is something a little special about this one right here at negative 3. What kind of 0 would that, what would be special about that 0 that's a little bit different than the others? It is real. If we can see it on the graph, if it crosses the x-axis, it's still real. It has a multiplicity of 2. Because if we have even multiplicity, we just like touch the x-axis and then go back down, or touch it and go back up. It sort of bounces off, right? See how the other 3 cross right here? Look at your equation. What was special about the 3 right here in our equation? It was squared. So really, if we wanted to, we could have written it out like this. 3x times x minus 2 times x plus 3 times x plus 3. We could have written it twice, because that's what it means when we have something squared, is that it's multiplied by itself twice. 2x minus 3. So that x minus 3 is a double 0. It has a multiplicity of 2 for that. It didn't ask that. I'm just giving you extra information here. Okay, questions? All right. All right, let's try to remember how to do the quadratic formula. Okay, I'd put it on my note card. You won't need it today on today's quiz, but you will possibly need it in the future, so I'd go ahead and put it on the note card. So it's negative b plus or minus square root b squared minus 4ac all over 2a. I don't know who taught that to you. Did he have a song? Was it like Sesame? Let's see. There's Sesame Street. There's like a chant. There's all kinds of songs. For our final exam, you would have to have that memorized, because they don't give us any formulas on our final exam. I would suggest putting it on your note card for me. So when we're doing, this is sort of a review here. When we're doing quadratic equation, we are going to do, we need something squared. We can't do this for like something to the 3rd or 4th or 5th power. So this only works if our highest exponent is squared. You have to have 2nd degree. And we've got x squared minus 5x minus 8 here. There's no number in front of that x squared, but there would be a 1, correct? And so our a is 1, our b would be negative 5, and our c would be negative 8. So we are plugging that into this equation, right? And we would have negative b, or a lot of times you'll say opposite of b. So if I do negative b, it's negative 5, which actually is just positive 5, right? Plus or minus the square root of b squared. So make sure you put that negative 5 in parentheses before you square it, or I just leave the negative off altogether, because when you square something, it's always positive. Minus 4 times 1 times our c is negative 8, all over 2 times 1. Now, we can type this all into Desmos, and we can get, well, we can't type it all in at one time. Desmos will not let you do the plus or minus in there. You'd have to type it once with a plus and once with a minus. In fact, let's do that. If we type this into Desmos, we'll be typing in 5, actually let's do 5 plus square root of negative 5 squared minus 4 times 1 times negative 8 all over 2 times 1. All right, and we get a decimal. You could copy this and paste it and change it to a negative. It won't let you do plus or minus, because really it's two separate values. So we get these two decimals. So that works great if we need a decimal for this, right? But a lot of times, they'll give you answer choices that are not decimals, or they'll be asking you for the exact answer. So if they do that, then you're just simplifying this here. So you'll have 5 plus or minus, and then you can do this part in your calculator or in Desmos. We can do the just the -5 squared minus 4 times 1 times -8. Just the stuff under the square root, we get 57. Square root of 57 all over 2. A lot of times, that's what the answer is going to look like for your answer choices. Now, you could always take that answer choice and plug it into Desmos and see if it gives you the same thing, because if you do 5 plus square root of 57 and divide that all by 2, see how it gives you the same decimal as when you type the whole thing in? That will also work. Or you could do it with a minus, and it gives you the other answer. Okay, let's look at where we'd have to use this. Okay? So, if I look at this, I'm supposed to find all the x-intercepts of the function below. So, the first one is not very difficult to find. I'm just doing 2x minus 3 equals 0. Add that 3. 2x equals 3. Divide by 2. X equals 3/2. Okay, this is the last question we're going to do too, because I need you guys to go ahead and do your quiz. We're running out of time. And then x squared minus 4x minus 10 would equal 0. And I could try to factor this, but this one will not factor. So this is where you would have to use that quadratic formula. So that number in front of your x squared is 1, so a is 1. B would be -4. C would be -10. So we're plugging it into -b plus or minus square root b squared minus 4ac all over 2a. And so for this one, it would look like this. -4 is going to be a positive 4, plus or minus the square root of -4 squared minus 4 times 1 times -10 all over 2 times 1. And so that is 4 plus or minus, that's going to give us 16 plus 40, square root of 56, all over 2. And technically that will break down, but I'm not going to get into that right now, because I don't think we need to. Alright, so you got these. This is actually 3 different zeros. You got 3/2, and then you got 4 plus square root of 56 over 2, and 4 minus square root of 56 over 2. So these would be, it's actually 3 answers since it has that plus or minus right there. Now, these are still real zeros. If you graph this on Desmos, which we don't have time to do, you can get the decimals for all 3 of these zeros. You're going to have 3 x-intercepts you can see, because they don't have an I. We will finish these up, not tomorrow, because we're going to do the NC check-ins, but on Thursday we'll finish up these notes and talk about imaginary there as well. One